Okay, I'll now discuss example 6. The points A, B, and C have position vectors a, small b, and 2a plus 3b respectively. Expressed in terms of a and b, the position vector of p if AP is equals to 2 of AB. Okay, so you know you are given this equation, so it will be wise to start from this equation, right? So you are given AP equals to 2 of AB, right? And you want to find the position vector of P. So what's that? Position vector of P is OP, right? So in order to find OP, I will need a few things. Okay, I will have to break down my AP, isn't it? And I know that AP can be broken down into OP minus OA. This is the formula. And yeah, so I can just reorder this to find my OP. So OP will be 2 of AB plus OA, and AB is given by OB minus OA. Okay, and then you further simplify this before you actually sub in your vectors to get the answer. Okay, so this will give you 2 times of B, and then OA is given by A. So 2B minus A. That will be the position vector of P. Okay, for part B, okay, you are given same thing. You want to try, you can pause the video and try now. You are given AQ equals to CA, and you're asked to find position vector of Q. So same idea, you have to find OQ. Okay, so to find OQ with this equation, I will have to rewrite AQ as OQ minus OA. And then CA can be written as OA minus OC. Right? And then I'll reorder this. OQ is equals to OA, bring over, add with the other OA, that's 2OA minus OC. And then OA is given by small letter a, OC is given by 2a plus 3b. But because it's a negative sign, we must remember to put the bracket around this. And then expand this. 2a will minus with 2a. My answer will be negative 3b. Okay. I can even extend this question and ask you what is the relationship between OQ and OB. Right, and then you should be able to tell that OQ is negative 3b, and then this is equals to negative 3 of OB, which means that OQ is actually parallel to OB. Okay, because it's a scalar multiple of the other and it's in the opposite direction. Right, so this is example 6. Okay, you can actually try example 7. Okay, pause the video and try example 7. Okay, I'll now go through example 7. Given that OR is R, RS is negative R plus 2S, and ST is R plus 3S. So given all this, express in terms of R and S the position vector of S. Okay, so that means I want to find OS, right? So which of these given equations will be useful to me in order for me to find OS, right? So you have OR and you have RS, you have these two equations. So this is probably the one that is more important or more useful to you. So given RS to be negative R plus 2S and OR to be R. Okay, So I can rewrite RS as OS minus OR. Okay, let me write this again. RS is equals to OS minus OR. Okay, so if I rewrite this, then I can say that OS is equals to RS plus OR. RS is given by negative R plus 2S, and OR is given by R. So these two are zero pairs, so I'm left with 2S. Okay, then we can do that for part 2 as well. Find the position vector of T that is OT. Okay, so we are given ST, so we'll use ST and rewrite ST as OT minus OS. Okay, and then OT will be equals to ST plus OS, and ST is given by R plus 3S. OS is 2S, which I found in part 1. So my answer will be R plus 5S. Okay, next one. A part 3. We are asked to find RT. Okay, so RT can be found by taking OT minus OR. And OT is R plus 5S, and OR is negative R. So this will give you 5S. Okay, now the question asks you, comment on the length of RS and OS. Right? So RT and OS. So RT is 5S and let me highlight that. RT is never mind, let me just write it down. Part B, RT is 5 of S, while OS is 2 of S, right? So how do I do that? Over here, I can divide both sides by 5. So RT over 5 is equals to S, right? And then I'll replace this with this. So this will become 2 bracket RT over 5, right? Which means that this is 2 over 5 of RT. So therefore, OS is 2/5 of RT. That's it. That's the length. Okay.